Okay, so let's take a look at last night's homework. Yep. We're going to take a look at a couple questions in particular. The first question we're going to look at is this one, which is awfully tiny. Three to the negative second times 3 to the negative 8.
What's that? Oh, number 4?
Yes. The common wrong answer was 1 over 9 to the 10th. What's wrong with that? Yep.
You don't multiply through the same number because they're not actually 3. It's 3 times the next one.
Good. We don't multiply the bases because that's not actually a 3. This is really a 3 squared. Okay, so we don't multiply the bases. So what should be the correct answer here?
3 to
1 over 3 to the 10.
1 over 3 to the 10th. Okay? But now let's look at this next question here. This one was a little bit later. 5a to the 3rd times 5a to the negative 5th. The common wrong answer was 1 over 5a to the 2nd. What's wrong with that?
Me? Oh. Well, 5 isn't part of A, so 5 would be the numerator, because it's not like part of the A to the 2nd.
Okay, so in 3 to the negative 2nd times 3 to the negative 8, 3 is the base here. What is it here? What's the 5 here? Well, A is the base, the 5 is the coefficient. So here we're going to actually multiply those together. What rule allows me to multiply those together? Commutative property. And how do I rewrite this with using only positive exponents?
25
Good, 25 over 8 to the 2nd. All right. This one was by far, oh no, not this one. 11g squared. 11g squared divided by g to the negative 4th. What do I want to do here? Where do I want to start? Yep.
You want to start subtracting the exponents.
Okay. So 2 minus negative 4 is
6.
positive 6. The common wrong answer here was 11 over g to the 2nd. How would we come up with g to the 2nd? What's wrong with that, yeah?
They subtracted 4 minus 2.
Yeah, the subtraction problem was wrong. So my suggestion is you actually write out the subtracting of the exponents so you don't make a silly mistake with the subtracting. Okay, with all those negative numbers it does get tricky. So let's go back in here. What is the actual answer? 11g to the 6th because it's a positive 6. All right, last question. This one was only 3% of us got correct.
The last one?
Nope, this is the last one we're going to look at together. 5x to the 3rd over 10x to the negative 3rd. The common wrong answer was 1/2. Let's talk about how to solve this problem. Where are we going to start? Somebody else. Where do you want to start? Yep. You want to start with the variables?
No, simplify.
Okay, you're going to simplify the coefficients first, and what do you get?
Yeah,
1/2. Okay, so that makes sense. I see where the 1/2 came from. But now what's the next step?
subtract the variable.
Subtract. We're not subtracting the variable. What are we subtracting?
The exponent.
The exponent. So let's write that out.
3 minus negative 3, which is 6.
Which is a positive 6.
Which means it's x to the 6th power over 2.
X to the 6th power over 2. So how did people get 1/2?
They thought that it was 3 3 minus 3, you did subtract.
3 minus 3, the subtraction again was wrong. So that subtraction piece, again, my suggestion is to actually write it out so you clearly see how to subtract and we don't make any mistakes with that piece. Yeah?
Why would you put the x, the 6 power on the numerator?
Because is my exponent here positive or negative? And where do positive exponents go? Any other questions that I didn't already go over? Those are the big ones, yeah?
I want to ask 0.5.
Oh, okay, all right. Because we're dealing with fractions, you want to leave them in fraction form. You don't want to turn them into decimals, okay? And also, we don't usually put coefficients of 1, so you probably just want to write this as x to the 6th over 2. Okay, we don't need coefficients of 1. Any other questions? Awesome.